Okay, good afternoon, everybody. So we're still in the string notebook, and we might be in this notebook even until the next lecture. It's quite a long notebook. So the next function, there's just a few more functions that I want to talk about that deal specifically with strings, and then we're going to move on to talking a little bit about memory, and then we're going to talk about one more function that deals with strings that can do a lot of what I've shown you already. So there's one function that you can use that will replicate a lot of the functionality I've already shown you. So str, chr, and rchr, these are functions that have funny names. I'm not sure why they're named this way. But they basically search a string for a character, and they give you a pointer to the character if it finds that character in the string. So it's sort of like index of in Java, right? Index of in Java returns the index of the first character, the first occurrence of that character in a string, right? Last index of returns the index of the last occurrence of that character in a string. So these are similar, except they return pointers to the characters instead of the indexes. You can get the indexes fairly easily though once you have the pointer. So the way you use it is you pass in a pointer to a character, right? Presumably it's in a string somewhere, right? You pass in a character that you would like to search for. Notice here that the character is of type int. It's not of type char. This is a historical thing. So this is one of the older functions in the standard library. So it comes back. So it dates way back towards near the beginnings of C. And so way back then, there was no special character type, or all characters were represented as ints. And so the input type here is int. Right? It's actually a character. It returns a pointer to the first occurrence of that character in this string here. Right? And strchr returns a pointer to the first character in that string that's equal to that, the last character in the string that's equal to that character there. If you want the index, you just use pointer subtraction, which I'll show you how to do in just a second here. All right, so here's sys220 in all caps. The first occurrence of the C, of the capital C, of course, is that C right there. The last occurrence is the fourth character in the string. So you can find the first occurrence like that, right? You get a pointer to that C, right? You can find the last occurrence of the capital C, and you get a pointer to the fourth character in the string there. If you want the index, then all you do is you take the value returned by first or last, right? And you subtract the pointer that is the pointing at the first character in the string, right? So the pointer that points at the first character in the string, well, you can just use the name of the array here if you want to. You'd also do address str0 if you like, right? So you have a pointer into the string somewhere, so first or last, right? Subtract the pointer to the first character in the string, and that gives you the index. So after 1999, this type was introduced to the language, so it's pointer difference type, or ptr diff _ t. Right? And so it's the type that can represent the difference between any two pointers. So it's a signed value, right? Because if you subtract two pointers, you can get a negative value. It's the signed analog of size _ t, right? Size _ t is always unsigned. Pointer difference type is the analog of size t, except it can be signed. Right? So that's how you get the index, right? Just subtract your pointer with the pointer to the first character of the string. Right? Once you have the pointers, you can of course go ahead and change whatever those the objects that those pointers are pointing at. So if I want to change the uppercase C's to lowercase c's, right, just dereference the pointer, right, and assign a value lowercase c to whatever it's pointing at, right? And the same thing with last. So if you run that little example there, right, you find that the index of the first C is 0, makes sense, right? It's the first character in the string. The last occurrence of C is at index 3, which is the fourth character in the string, right? And after dereferencing those pointers and reassigning a value to them, right, I can get sysc with lowercase c's instead of uppercase c's. Right? So if you want to search a string for a character, strchr or strchr. if you want to search a string for a substring, str, str, right? So it's the exact same thing, except now you're searching for the start of a substring in a string. Works the exact same way, right? So here's your pointer to a so that's the substring you're looking for, right? It's going to search that string for the first occurrence of that substring, returning a pointer to the start of the substring if it finds one. I forgot to mention back here. So if that character is not in the string, you get back the null pointer. Right? So it is important to test the return value of these functions to make sure that they are not null. Right? Unless you know for sure that the thing you're looking for is in the string. Right? Generally, you don't, so you have to test the return value for null. Right? So here's an example of a function where a return value of null is actually meaningful. Right? It means the character is not in the string. The exact same is true for str, str. Right? And so the example, there's a little program here that you can use that tests it. So you call it by running sub str. Right? Pass in the string you want to search, the substring you're looking for. Right? And this thing tells you whether or not it occurs in the string. Right? So we just call str, str. Right? Search the string for substring. Right? Look at the return value of the pointer. Right? So if the pointer is null, that's what not p means. Right? That means the substring is not in the string. Right? So you get a little message here that says the substring is not in the string. Right? Otherwise, you again just subtract the returns pointer with the pointer to the first character in the string you're searching for, and that gives you the index of the start of the substring. Right? And so if you want to play around with this program, you've got access to it. Right? It's more or less the exact same thing as the strchr example. Okay, so that's it for the string-specific functions. There are more functions. There's not a lot more of them, though. But there are a few more functions. If you want to, you can look at them in the... So you just search for the string.h, right? And you'll find all of the... you'll find the documentation for all of the functions that operate on standard strings in the standard library. Memory manipulation. So oddly enough, the memory manipulation some memory manipulation functions are also defined in string.h, which is a bit odd, but that's where the language designers put them many years ago, so that's where they stayed. So there's two functions that are worth talking about. One's memcopy, one is memmove. They do almost the same thing, but one has a restriction that the other does not. Okay, so memcopy, where there's no O, right? And memcpy. So it is the language says it is supposed to be the fastest way to copy a chunk of memory from one location to another. Right? So it's the fastest standard library routine for doing this. Your operating system might have faster routines yet. So it's possible. It's probably unlikely because memcopy is probably calling those routines. But it's really your operating system that's going to be doing the heavy work here, right? So the way memcopy works is it copies a specified number of bytes. And unfortunately, it's written like that. So size t count. So that's the number of bytes that you would like to copy, right? You have to remember that in C says a byte is a multiple of a car equals 1 byte. So this is just the number of multiples of car that you would like to copy. Right? If you want to copy ints or doubles or something like that, you just multiply the number of things you want to copy by size of whatever, right? Size of int or size of double. There's your pointer to the start of the memory that you would like to copy from. And there's your pointer to the starting location of memory where you would like to copy into. Right? So you can easily use this function to copy parts of an array into another array. So if you want to do that, then this is the function that you would probably want to use. Right? And this thing returns a pointer equal to that. Right? So it always returns a pointer back to the start of the destination location. All right, so to use this thing, it's pretty straightforward. You just have to remember that this thing is not the number of things you want to copy. Rather, it's the number of bytes that you would like to copy. So I'm going to use this to copy an array into an array, part of an array into an array, and part of an array into part of another array. Right? So here's a little function that prints an integer array. So it just prints out the array like you would see in Java, right? Square brackets and then the elements of the array. That prints a double array. So again, same thing, except it prints the contents of an array of double values. And now we're just going to use memcopy to copy some memory around. So here's an array of ints, right? It's of length 4. I'm going to copy the array x into the array y. Right? So how do you do that? Well, you just use memcopy. Right? So memcopy, source. So destination always comes first. So y comes first. That's my destination. X is the source. Right? How many bytes would I like to copy? I'd like to copy 4 times. I'd like to copy 4 ints. So 4 times the size of int. Right? And so when you do that, these 4 ints here gets copied into y. Right? And y is big enough to hold those 4 ints, so there's no issue. So when you do that, right, our array y has the values 1, 2, 3, and 4 in it, just like we wanted. Okay, so here's an example where I copy part of an array into another array. So here I'm going to copy the last 4 elements of DBL, and I'm going to copy it into the array CPY. Right? So again, destination pointer, so that's just CPY, right? It's just at the start of the array CPY. Right? Source pointer, so I just want the, I want to start copying from the 4. Right? So I need a pointer to the 4, so that's just DBL plus 1, 2, 3. Right? So that's DBL plus 3. Right? How many bytes of memory would I like to copy? I'd like to copy 4 times the size of double bytes. Right? I'm copying 4 double values. And so when you run that, right, your destination array is -4, -5, -6, and -7. Right? And of course, you can now copy, now that we've done those 2 examples, we can now copy part of an array into another part of an array. So there's my source string. This is the destination string. I'm going to start copying from source plus 5. Right? So there's source plus 0. That's plus 1, that's plus 2, that's plus 3, that's plus 4. So that's plus 5. Right? So I'm going to start copying that, I guess. Right? And I'm going to copy it into dest plus 4. Right? So there's dest. Right? Plus 1, plus 2, plus 3, plus 4. So it looks like I'm going to overwrite the what with that. Right? And that's exactly what happens. Right? I'm going to copy 4 bytes here. Right? You can write count times size of car if you want to, but size of car is always 1. So count is sufficient here. Right? And that replaces the what with that in the destination string. Right? So if you're trying to copy memory around, memcopy is probably the function you want to, is one of the 2 functions you want to consider. There is one restriction on memcopy that is important. Okay, so the result is undefined if you try to copy memcopy in a nonsensical way. Right? So for example, if you're trying to copy memory that doesn't exist, right, it's outside of the bounds of the source or destination object. Right? So in other words, you try to copy past the end of the source array or copy past the end of the destination array, bad things can happen. Right? If either source or dest are null pointers, bad things can happen. Right? Remember, null means no object. So if you're trying to copy no object into no object, that's bad. Right? You're trying to copy something into no object, that's also bad. Right? But the important restriction, so those 2 are basically common sense. It's the last one that's important. So often you're going to run into a situation where you have an array and you would like to copy part of that array into the same array. Right? So you've got some array here. I guess for those of you who are watching the video, I just drew a big array. Right? And so I'm going to draw a chunk of the array. So that's going to be source. So I'd like to copy those elements, and I'd like to copy them into the same array. Right? So what's not allowed to happen is that the destination array cannot overlap with the end of the source array. Right? So if that happens, the memory that overlaps, it's not clear if that's copied correctly or not. Right? And it depends on the exact implementation of memcopy. In most cases, that memory will not be what you expect it to be. Right? So this memory here, you would expect to be the first few bytes of SRC. In most implementations, that probably won't happen. And so you won't get the correct copying to happen. Right? On the other hand, you might happen to have an implementation where it does work correctly. Right? The behavior is undefined. So if the source and destination parts of memory overlap, you have to be careful about using memcopy. If they do overlap, then you can always use memmove. So memmove is exactly the same as memcopy, except it handles the case where the source and destination memory overlap. Right? You even call it in the exact same way. Right? Number of bytes to copy, right? Start or a pointer to the start of the memory that you'd like to copy from, pointer to the start of memory where you'd like to copy into. Right? Exactly the same thing. Right? It's called memmove, but the move part is a bit deceptive. Right? The function actually copies bytes from the source object. Right? It doesn't actually move them from the source object. Right? So in other words, your source object is unchanged by this function. Right? It really is copying, but it's called memmove because you can't have two functions called memcopy. Right? You're not allowed to have two functions with the same name. So they called it memmove. So if the memory that you're copying from and into overlap, consider using memmove instead. Otherwise, it's the exact same. So it's almost the exact same example here. Here's the array 1, 2, 3, 4, 5, 6. Right? I think somewhere in here it shows you that the memory can overlap. Right? So it's going to print out that array, so you get 1, 2, 3, 4, 5, 6. Right? My destination pointer is going to be x plus 4. So there's x plus 1 plus 2 plus 3 plus 4. So we're going to start to write into, we're going to copy over the 5. Right? Source is des plus 1, so the 2. Right? And I'm going to copy how much? Count. Count is 6 minus index minus 1. Why did I make it so complicated? 6 minus 4 is 2 minus 1. So I'm going to copy one value, it looks like. So I'm going to copy the 2 into the 5, I think, is what we're doing here. Before, did I do that right? Memmove. Source, des plus 1. The 2, right? Oh, no, I'm sorry. I'm being a dummy. It's des plus 1. So it's 1 after the destination, so it's going to be the 6. So we're going to copy the 6 into here. And so that's exactly what happens. Right? Notice that the destination and source arrays overlap. Right? So the source array is, or the source memory is that, right? And the destination memory is also that. Right? And so this does what you wanted to do. It copies that onto that. Right? And I think the intent here was to adjust index. So if I make this smaller, so I make it 3, our destination array is x plus 3. So 0, 1, 2, 3. So it's going to start copying onto there. Right? And it's going to copy, in this case, I think the 5 and the 6, it's going to copy on top of the 4 and the 5, I believe is how this works. So let's see what happens here. And yes, so it copies the 5 and the 6 onto the 4 and the 5. So you get 5, 6 here, where the 4 and 5 used to be. Right? And if you keep on making the index go down, right? So now it's going to copy the 4 and the 5, the 4, 5, 6 onto where the 3, 4, 5 used to be. Right? And now it'll do 2 through 5, where the, so 3, 4, 5, 6, where the 2, 3, 4 used to be. 2, 3, 4, 5 used to be. Right? And so on and so on and so on. Right? So if the source and destination overlap, use memmove instead. Right? So memcopy and memmove are going to show up a little bit later when we start to talk about implementing a data structure of some kind. So we're going to implement an array-based data structure, and we're going to start. We're going to have to manipulate memory ourselves. Yes.
If memmove is just sort of more predictable, is there any reason why you shouldn't be using memmove?
Yeah. So memcopy is slightly faster. Yeah. I think people have benchmarked it, and it's not really it's not a massive difference. But you could be in a situation where you're trying to squeeze every little bit of performance out of your application. All right, so a lot of the functions that we talked about, so not memmove or memcopy. Memmove and memcopy, you can use those to copy strings as well, right? So you can use those in place of strcpy. Things like concatenating a string, copying a string, and doing other things with strings. Often you can do all of those operations just by using sprintf, right? So we've seen printf in the course, right? We know printf prints stuff to standard output. Sprintf, instead of printing it to standard output, it prints the contents into a string, right? That's all. That's the only difference. So to call sprintf, you say you give it the string that you would like to print into, right? So you pass it an array or part of an array of car, right? And so we call that's just called a buffer, right? If you ever see the term buffer, it just means a chunk of memory, right? Which is the same as an array. So you pass it a string that you'd like to write into, right? And the rest of it is exactly the same as printf, right? Behaves exactly the same, except now the output goes into a string. The returned value here is int. And so the return value is the number of characters, not including the null terminator, that was written into the buffer. Now, because this is one of the string printing functions, right, print into a string, the function guarantees that the null terminator is always written into that array. Right? So you don't have to worry about writing the null terminator yourself. The function will do it for you. Right? What do you have to watch out for when you use this function? Well, you have to make sure that whatever string gets printed into this array, right, that array is big enough to hold the string plus the null terminator. Right? If that array is too small, the function just overwrites all the memory after the array. Right? And again, bad things can happen, right? Undefined behavior. Right? Undefined. Right? So this is a very common feature of C. Right? Many of the functions will say behavior is undefined. And this is one of the problems with the C programming language. The fact that behavior can be undefined is awkward to deal with. Right? It's really awkward because often, again, like when you write these little test programs, the test program seems to behave properly. But if you're falling into this undefined behavior, the fact that it's behaving properly or seems to behave properly also falls into undefined. Right? It's not until later when you try running your program in a larger context that your program might start to crash, or you might start overwriting data or something like that. So when you're working in C, you have to keep in mind you have to be very careful about this undefined behavior business. All right, so buffer has to be big enough to hold the string that was written into it. Your formatting string has to be a correct formatting string, right? So you can't make up your own conversions, right? And finally, the sprintf does not like it if your destination array, so if your buffer overlaps with one of your data arguments here, right? So you're not supposed to use this thing to print part of a string on top of the same string. So you have to be a little bit careful there too, right? All right, so this function will write stuff over here, right? Data here into this array here, right? So if this data is a string, right, you can write that string on top of this string here. So this is exactly, you can get the behavior of string copy, right? If this is a string over here and you choose to write to the end of another string, that's the same thing as strcat, right? String concatenation. Okay, so here's my source string 0, 1, 2, 3, 4. Right? I'm going to emulate the behavior of string copy. Right? So I need a destination array that's big enough to hold the string 0, 1, 2, 3, 4 plus the null terminator. Right? So it needs to be of length 6. Length 6. Right? So string length is the length of src, right? So length plus 1 to make sure I can hold the null terminator, right? And that's yet another way to copy a string in the C language, right? Just use sprintf or sprintf, right? So print the source string into the destination string, exactly the same as copying a string. Right? If you run that, right? So there's your source, there's your destination, right? There's your number of characters that were written into the destination array, right? 5. It's actually 6, right? It doesn't tell you, it doesn't say 6 even though it writes the null terminator into the destination array. Okay, so you can copy into the middle of the destination array as well. Is that right? Yes, okay. So here's my destination array A, B, C, D, E. Right? So now I'm going to replace the hyphens with the 0, 1, 2, 3, 4. Right? So that's what I would like to print. Right? I'd like to print the source string. Where do I want to print it to? I want to print it to dest plus 0, 1, 2, 3, 4, right? Which is the length of the original string. So when you run that, right, your destination string becomes ABCDE 0, 1, 2, 3, 4, right? And 5 characters are written into the destination string. Right? So if the, copy the end of a string into a destination array. So if you imagine that those hyphens weren't there, right? But the destination array had enough room in it, right? So for example, I'm going to get rid of these, and I'm going to say the destination array has room for 100 characters in it, right? So now when I run this, right, that's exactly the same what you would get if you did string cat instead, right? So I concatenated the string 0, 1, 2, 3, 4 onto the end of A, B, C, D, E, right? See, all you do is you write to the end of the destination string, right? So that string cat, you can also get the exact same behavior just using sprintf. And of course, finally, you can write part of a string into the destination. Sorry, I can write part of this string into this array here, right? So I think here I'm writing the 220 into dest4. Right? So what string am I writing? Well, I'd like to write the 220 part of sys220. Right? So I need a pointer to the first 2. So that's s, right? That's s plus 1, plus 2, plus 3, plus 4. Right? So there's my source string. Right? I'm just going to write into the beginning of dest4, right? And you can see down here that we get 220 down here. Right? All right, so in Java and Python, if you want to concatenate stuff together, it doesn't even have to be strings, right? You want to concatenate like anything to anything. And, well, the string representation of anything with the string representation of anything in those languages, right? You just use plus, right? Or when you print it in Python, you just use commas and separate the arguments, right? So if you want Java-like string concatenation, right, there is no operator overloading in C, so you can't use plus. What do you do instead? You just use sprintf. Right? So here's a string sysc. Right? Here's the number 220, and here's the character A. Right? In Java, I can just write department plus num plus section, right? And you get sys220A. Right? So what do you do in C? Well, you use sprintf instead. Right? So %s to convert the department. Right? %u to convert the number. Right? %c to convert the section. Right? So convert the department as a string, convert the course number as an unsigned integer, convert the section like it was a character, write all of that into the destination string. Right? So you get similar functionality as Java's concatenation operator. It's just a lot harder to do. Right? You have to use this function. You have to remember what these conversion specifiers are, right? And then you have to pass in your arguments in the correct order. Right? But it does work. Right? So you do, in fact, get sys220A here. Right. Next one looks like a date. So I've got the date as numbers. Right? 2023, 10, and 3. This tells you how to do the assignment, by the way. Right? If you're still working on the assignment. The 04U says use a minimum field width of 4. Right? Anything that's not used for the output, write a 0 in instead. So pad the beginning of the numbers with a 0. U means unsigned int. Right? There's the hyphen between the year and the month. Right? 02U, so print the month out using 2 spaces. Right? If you only need 1, put a 0 in front. Right? So you get 05 instead of just 5. Right? Hyphen and then the day, exactly the same as the month. Right? So there's 2023, 10-3. 1003. Right? So notice the 02. Right? The effect of that is to use 2 characters to print the result, right? And pad the result with zeros if you don't need 2 characters to actually print the 3. And finally, the postal code here. Yes, the .3. So there's my string A1B2C3. Right? I'm going to write the postal code into the string formatted, and I'm going to insert a space in between the AIB and the 2C3. Right? So I haven't shown you how to do this yet. So right here, we're going to convert a string, but there's a 0.3 in front. So when you're converting a string, you can say how many characters to convert from that string. Right? So that's what the 0.3 means. Right? The 0.3 means take only 3 characters from the string P code. Right? So it's only going to take the A1 and the B. Right? So you can specify the number of characters to copy from a source string when you write it into the destination string. Right? And so this is if you know how long the destination string is, this is one way to make sure that sprintf does not write past the end of the destination string. Right? So for example, if you knew your destination string had room for 10 characters in it, you could write 0.9 here. Right? And that will guarantee that sprintf never writes more than 9 characters plus the null terminator into your string. Right? So you can avoid the whole write past the end of the array issue here. Right? Followed by a space, right? Followed by 3 characters from P code plus 3. Right? So remember, P code is a pointer to the A. Right? So plus 3 is 1, 2, 3. So it's a pointer to the 2. Right? So take 3 characters starting from the 2, so that's 2C3. Right? And you get the formatted postal code down there. And that's it. Right? So sprintf, super handy if you remember it's there. Right? Often, so I personally often forget it's there. And then I end up using the standard string functions instead, even though you can do most of it with just sprintf on its own. I don't think there is a preferred way to do it. I guess you can consult Stack Overflow to see what they think about that. I suspect all the functions run in are all more or less the same in terms of performance. All right, so we know how to write into a string, which is handy, right? You can also read data from a string, which is also handy, right? So there's a common problem that occurs in programming, especially when you're processing text data, right? And that is you want to extract information from a string, right? And you want to pull stuff out with some sort of format, with some sort of formatting information, right? So using the date example again, right? If I parse that string, it might be nice to get out the year, month, and day as integer numbers. Right? I'd like the 2023 as an int, I'd like the 01 as the int 1, and I'd like the 29 as the int 29, for example. Right? And so we've seen the printf family of functions. There's also a scanf family of functions. So printf outputs stuff, scanf reads stuff. scanf reads from a string, right? So it reads formatted information from a string. So the way this works is that's the string you're reading from, right? This is a formatting string, so it's similar to the printf formatting string, right? So you have to say %s, for example, to print a string, right? If you want to extract a string from another string, you would also say %s, right? If you want to extract an int from a string, you would write %d. Right? Now the ... is a little bit different. Where'd it go? Back here. Okay, so the ... Okay, so when you call printf, right, you just pass it the information that you would like to print, right? Scanf needs to write information into the variables that you're going to pass to it, right? So this ... these are the variables that you want to store the information in, right? Now remember in C, if you want a function to write into one of your variables, what do you have to do? Right? You have to pass it a pointer to your variables, right? So all of these things here are pointers. Unless it's a string, right? A string is already a pointer. So if it's a string, this is not a pointer to the string. It's just the string itself. Right? So these are going to be pointers where the scanf can write the data into. So these things here are called the receiving arguments, right? They're the variables that get the values that scanf reads from the string. Int, the return value here, is the number of receiving variables that were written into successfully. Right? So it's the number of successful conversions that scanf managed to perform. Right? So the way scanf works is it starts reading the string from left to right, and it tries to fill in or tries to follow your formatting string here. Right? So it's going to try to match characters and conversions in the formatting string. Right? And it stops reading as soon as a failed match or conversion occurs. Right? So in other words, if it tries to convert something, if it reads something in the string and tries to convert it as an int and it fails, then it stops. It stops reading the rest of the string at that point. Right? So the return value is equal to the number of receiving arguments that are successfully assigned to. Right? If none of the receiving variables are successfully assigned, you get the value 0 returned. Right? Now, it can be the case that you get back this value EOF, and you don't know what that value is. I think on most systems it's -1, but you don't know what it is. Right? So it's possible that scanf reaches the end of the string that it's reading before it even tries to make a conversion. Right? And so that happens, you don't get 0, you get EOF instead. All right, so let's take a look at an example of a few examples of this function. Why did I call it data? Anyway, it's probably supposed to be date. There's a date, right, stored as a string. Right? I would like to extract the year, month, and date from that string. Right? So here are my variables, year, month, and day, that I'm going to use to store the year, month, and day. Right? So what is the format of this thing as far as scanf is concerned? Right? So I'm expecting my date to be an unsigned number, right, followed by a hyphen, followed by an unsigned number, followed by a hyphen, followed by an unsigned number. Right? So when I call scanf, right, I tell it which string am I trying to read, so I'm trying to read the string data. Right? What is the formatting of that string? Right? So you pass in the string that it describes the formatting of the string. Right? And now I pass it the variables or the address of the variables that I would like to store the information into. Right? So I'd like to store the year, right, or the first number as the year. Right? I'd like to store the second number as the month, and I'd like to store the third number as the day. Right? So whatever you do here, right, don't make that a pointer. Right? So a very common mistake is to make the year variable a pointer, because you look at the function and it says the function needs pointers. Right? That's the right. That's the type of these things up here of the ... Right? It's pointers to the values that you to the objects where you'd like to store the information into. Right? So here, don't make a pointer to year. Right? If you make a pointer to year, you don't actually have an unsigned int object. Right? You just have a pointer to one. Right? You need the object to write the value into. Right? So here you want the address of year. Here you want the address of month, and here you want the address of day. Where year, month, and day are not pointer objects. Right? They're unsigned int objects. Okay, so this thing returns the number of conversions. So if you get EOF, that means it tried to reach the end of the string before ever attempting a conversion. If you get 0, that means it was not able to successfully convert the year. Right? So the first thing it tried to convert was unsuccessful. Right? It could not convert it as an unsigned int. Right? If the number of conversions is greater than 1, then I know for sure it managed to read in the year. Right? It was, greater than or equal to 1. I know for sure it read in the year. If it's greater than or equal to 2, I know it successfully read in the year and the month. And if I know it's equal to 3, I also got the day. Right? So if you run that, we get 20, 23, 1, and 29, which is good. Right? So if I make the 29 not an unsigned int, right? So ABC. Right? So here only the year and month were extracted successfully. Right? So I put that back to 20. So what happens if I do 29A? So what does it do with that? Right? So you run that. So it also gets out the day. Right? And so what happens here is it follows this formatting string. Right? And so it starts to read data from the left. Right? And it says try to pull out an unsigned int. So it reads as many characters as it can, right, before it reaches something that's not part of an unsigned int. Right? So the next character that it reads in will be the hyphen. So it knows that Right? So that is your unsigned int. Right? Your formatting string then has a hyphen in it. So the data also has to have a hyphen in it. Right? So for example, if you change this to a colon, it's only going to read in the year now, right? Because the colon here does not match the hyphen that's down here. Right. Similarly, so I should show you something else. This will work. Right? So for most of the conversions, not all, right? For most of the conversions, leading white space is skipped, right? Which sometimes gets you into trouble, right? So here, even though it says %u, right? Really what this means is read in the rest of the string ignoring white space until you can read in an unsigned int. Right? So it ignores all of this white space, right? Then reads in the 0, 1. Right? Trailing white space, so notice the difference here. Right? Trailing white space is not ignored. Right? So here it's space, space, hyphen. Right? But that's just a single hyphen down here. Right? So it does not ignore the spaces here followed by the hyphen, right, before reading in the hyphen. So if you have a character or characters here that are not part of a conversion specifier, right, those have to be matched literally. Right? So that has to match there. Right? The 29A gets read as 29. Right? It then reads the A and it says, okay, that's not part of an unsigned int. But the 29 is an unsigned int. Right? So that successfully gets read into day. Right? You could continue processing this string, right? So if the formatting string was %u, %c, it would then read in the A successfully. Right? %u, %s will also work, right? It'll read in the A as a string. Okay, so if you play around with the data string, you can see the effects of the output on the scanf function. And so I guess if you need to review this, the notebook does tell you in greater detail exactly how it's doing the matching here. Okay, so most conversion specifiers consume and discard leading white space. Right? So this will successfully convert. Right? That'll convert as 2023 129. Right? Where is it? Oh, what happens if there's space in the format string? Right? So if there's space in the format string, a single space will match 0 or more consecutive white space characters. So here this says read an unsigned int. Sorry. Read in an unsigned int, followed by 0 or more white space characters. White space is space, tab, or a new line. Right? Followed by a hyphen, followed by an unsigned int. Remember, when it says followed by an unsigned int, it means followed by 0 or more spaces, then an unsigned int. Right? So that conversion will match any one of these here. Right? All right, so it turns out there's a lot of conversion specifiers. You don't have to memorize them, right? Like you should know %d and %s and %c, right? D is for base 10 int. I guess %u is for unsigned int. It's kind of obvious, right? %f is float. %lf is double. %s is a string. %c is a car, right? Don't memorize these. On the exam, you always get a reference sheet. The reference sheet always contains enough information for you to be able to solve the problem that you're trying to solve. Right? So if there's a problem that asks you to read in a bunch of unsigned ints, right, you'll be told what %u does, right, in your appendix to the exam. Right? So don't bother memorizing the conversions. Look them up when you need them. Right. All right. So here is what are we doing here? Oh, there's a lot of it. Okay, there's a bunch of them here. So I have variables. These are all variables to store information into. Right? So these are not. These are what I'm going to write into. Right, so str1 and 2, I can write in a string of length 99, followed by the null terminator. Right, x1 I can write in an unsigned int, y1 I can write an int, z1 I can store a double, and c1 I can store a car. Right. Okay, what happens if you scan the empty string? What the heck happens? Right, so when I scan the empty string, this is when I get EOF. So here we're trying to scan the empty string, so when scanf runs, it gets to the end of the string, and there's nothing to convert. Right, so now you get EOF, and on my computer, EOF happens to be -1. Right, and so this is printing out n, the number of successful conversions. So the same thing is true if you try to scan an empty string, right? So here the conversion specifier is %s. %s ignores leading white space, right? So it tries to read in a string, ignoring any leading white space. So when you give it a string made up of only spaces, it ignores all of the spaces, right? Then it runs out of characters to read. So again, you get -1 as the number of conversions attempted. Right. Okay, so here's the string ABC. Sorry. Sorry. Yes, here's the string ABC. I'm going to try to read the ABC as an int. Right? I'm going to try to write the result into y1. I guess y1 is a regular int. Right? So obviously that is not an int. Right? So when you run this, right, here you get n equals 0. So no successful conversions were made. Right? You don't get -1 because it didn't get to the end of the string, right, before any conversions were attempted. Right? It read the A. Where'd it go? It read the A. Sorry, it read the A, right, realized that was not an int, and stopped. Right? So you didn't get to the end you did not get to the end of the string, so instead of getting EOF, you get back 0 instead. Right? Okay, so here is read the string ABC like it was a string. So this should work. Right? So it does, right? So it reads the string ABC. There's your one conversion, right? Stores ABC in str1. Right? Notice with strings, right? So when you're writing into a string variable here, right? You don't pass in the address of str1, right? The address of str1 is the address of the pointer, which is not what you want, right? You want to be able to write into the character pointed at by str1, right? So remember, str1 is the name of the array is synonymous with the pointer to the first character, right? So this is exactly what you want here, right? So don't take the address of a string when you're passing it as a receiving argument of scanf. Okay, there's a string with a space in it. So the way %s works is it'll read a string, but it will stop at the first white space character, right? So ignore leading white space, read in everything that's not white space, and as soon as it hits another white space character, it stops. So this does not read in the string ABC XYZ. It only reads in the string ABC, right? And then it leaves the space XYZ, so it stops after reading the C. And so there it is right there. Right? This is the confusing thing about doing string conversions. Right? Often you want to convert that as a single string. Right? You can't do that with %s on its own. Right? %s will stop at the space. Okay, here's ABC space 1 XYZ. Right? So how can I read all of that information in? Well, that's a string, that's an int, or an unsigned int, right? And that's a string. So if I use the conversion specifier %s, %u, %s, right, that will let me read in string, unsigned int, string. Store the first string in str1, store this int in whatever x1 is pointing at, in x1, right, and store the second string in str2. Right, here you should get 3 successful conversions, and you do. Notice that you can read, never mind. I was going to say you can read in an int as a string if you want to, right? So if you made that %s, you could also write the 1 into a string variable. You can't write it into x1 though. x1's unsigned int, right? So that won't work. Scan a non-blank string for int. Okay. -99 ABC, right? I'm going to try to scan that string for 1 int. So this actually works, right? It sees the -99. Then it sees the A. So it converts the -99 to the int and to an int and stores it in y1. Right? So 1 successful conversion, right? Storing the value -99. There's the string -99, followed by a space, followed by a comma, followed by a bunch of spaces, followed by -1.5. Right? Remember, trailing space you can't. It won't ignore unless you tell it to. Right? So I'm going to read in an int, followed by 0 or more spaces, followed by a comma. Right? This leading space here doesn't matter, right? %LF read in a double value, right? You do need the L here, which is inconvenient. So if you don't put the L in here, you'll get a warning from the compiler, right? So that works correctly, right? You get the -99 and you get the -1.5. Notice that the comma, right? It's matched in the formatting string, but it does not count as the number of conversions. Am I over time? I'm way over time. Someone should have said something, sorry. I guess I have to stop there. So I guess we'll finish this up. Yeah, there's still a lot more in the next lecture.